All right, welcome back on this road to being able to find the derivative of a logarithmic function. Today, though, we're going to go ahead and recall and redefine or define what a logarithm is. Again, from pre-calculus, you should have spent some time on logs, but we're going to spend a little more time today going over them and being able to write them, expand them, and that sort of thing. All important as we get into the derivatives of logs. So by definition, what is a logarithm? Well, a logarithm is just a math function, a function in mathematics. And what it allows us to do is to change something that's in exponential form into logarithmic form. So it's a relationship between the exponential form and that logarithmic form. So if we let x equal y to the a, so if some number equals y to the a, what does that mean? Well, we know, say if I gave you 3 squared. We know 3 squared equals 9, don't we? Hopefully, yes. So our y there would be 3, our a would be 2, and our x would be 9. So we know that 3 squared equals 9. In logarithmic form, we can say that log base 3 of 9 equals 2. So what it does is it rewrites this exponential form so that we have that exponent equal to a log. So we can change this to log base 3 of 9 equals 2 because we know that 3 squared equals 9. And that's really what you want to see in this. You should see this exponential equation down here in this logarithmic equation if we were to kind of rearrange the numbers. So we have 3 squared equals 9. And what we're going to do is practice just a little bit here. Can we write 2 to the third equals 8 in logarithmic form? And we can. So we can have log, our base is 2. Our number we're taking a log of is 8. And that's going to equal our exponent of 3. Again, we see that that 2 is subscripted for the log. And then 8 and 3 are kind of equal with log up there as we write it. So 8 and a 3, same size as that log. That 2 is subscripted. So we have log base 2 of 8 equals 3. Can we write log base 3 of 27 equals 3 in exponential form? Again, our base is 3, so we have 3 to the exponent of 3 equals 27. And this should always make sense to us. 3 to the third, we should know 3 to the third, and that is going to equal 27. So being able to write a logarithmic form in exponential form should just be going to something that we are fairly familiar with. Being able to solve for x, so if I have log base 3 of x equals 4, can we write that so that we can solve for x? So what x is x? So we're asking ourselves 3 to the 4th equals what? And 3 to the 4th is 81. So we end up with 81 equal to x. So the next thing I want to do is go over the log rules. And these, again, should be familiar to you, and you should be able to go through these fairly quickly. If not, you can pause us. If I have the multiplication of 2 quantities, and I'm taking the log of them, I can break that up into the addition of the 2 separate logs. Notice our base stays the same. If I'm dividing, I can split that up through subtraction. So this is when we were expanding our logs last year in pre-calc. If our base and our number are the same, it's going to equal 1. So if you think b to the first power is going to equal b. So it doesn't matter what our base is. As long as we're equal to 1, we know that we're taking a log of that same number as the same base, as the base is. If it's equal to 0, then we know that the base to the 0 power has to equal 1. Probably one of the more important values or log rules is the exponent rule, where we can take that y, that exponent, and we can bring it to the front through multiplication. So we have y log base b of x. We have log base 10. So if we don't have a base with the log, we understand it to be 10. Just like the coefficient of x is 1 when it's not written. So if there's nothing written there, it's a base 10. We call this the common log as well. That's what we normally use. Our calculators are set up in common logs base 10 because we're in base 10 numbers. We have 10 digits in order to be able to get to our next, or to make up all of our numbers. Log base e is the natural log. So natural log. Remember, natural log goes with our e. E is an exponent, is a number that we see out in nature. Things that grow exponentially in nature grow with a base of e. Then natural log of e equals 1. So if you think about natural log was log base e, so I have log base e of e equals 1. And that goes back up to this rule, where we have log base b of b equals 1. So if the base and the number that we're taking the log of are the same, it's equal to 1. Here, the exponent, or the base and what we're taking the log of are the same, so it equals 1. So an important rule as we get into solving exponential equations. So for the rest of the day, we're just going to go ahead and expand a little bit. Very important, again, as we get into derivatives, that we're going to be able to expand our logs and natural logs. So we're going to use those law of logs, logarithms, in order to be able to expand this out. The big thing that you need to remember is that if we take the log of a fraction, the numerator is going to be positive logs, and our denominator is going to give us negative logs. So I can break this up into log base 4. Here I have x minus 4 to the third times. So I have log of base 4 of x minus 4 to the third. If I multiply, I can break that through addition. That's our first rule that we were talked about. So log base 4 of x plus 1 squared. And I'm dividing by x minus 2 to the third. So if I divide, I can break that up through subtraction. So I have log base 4 of x minus 2 to the third. And now I can bring all my exponents through the exponent rule, and I can multiply those to the front. So I have 3 log base 4 of x minus 4 plus 2 log base 4 of x plus 1 minus 3 log base 4 of x minus 2. And that's our expanded form. We can expand this one as well. Again, if it's in the numerator, it's going to be a positive log. Denominator is going to be a negative log. So we're going to start out with a positive log. No base, so we understand it to be 10, and we don't need to rewrite that. We understand it to be 10. And to that, we're going to add the log of 2x minus 1 to the third. And we have a subtraction. Since we have division, we're going to have the log of 3x plus 1 to the fourth. Again, I can bring all my exponents to the front through my exponent rule. So I have 5 log x plus 3 log of 2x minus 1 minus 4 log of 3x plus 1. And that gives us our expanded form. Lastly, today, before we finish up here, I'm going to go ahead and write things as a single log. So can I bring this together? Can I condense it into a single log? So the first thing I got to do is make sure that my bases are the same. So my bases are all 3. So I can go ahead and definitely do that. And if you recall from the previous examples, if it was a positive, or if it was in the numerator, it was positive. Denominator, it was negative. So my positive logs, my first one here is going to be in the numerator, and my last one is going to be in the numerator. So I can go ahead and bring my x minus 1 with my 4 log base 3 of x. So I can bring that exponent to the front, or to the, as an exponent, to the fourth. I'm going to multiply it to my x minus 1 in the numerator, since it was a positive log. I'm going to divide by my negative logs. Again, I can bring this coefficient of 3 up to my exponent and get x plus 2 to the third. And then finally, I'm going to go ahead and condense this one, right, as a single log. Again, if it's positive, it's in the numerator. If it's a negative log, it's in the denominator. So I have log base 4. My x minus 5 is by itself in the numerator. There's no exponent, since there's no coefficient. My x, again, has no exponent, since we don't have a coefficient. But my x plus 1 is going to have an exponent of 3, since that was the coefficient. Again, that was a negative log, so we're going to put it in the denominator. Again, positive is in the numerator, negative is in our denominator. And that gives you kind of an overview, a review of what we should remember from pre-calculus and our definition of what a log is, how to write or rewrite logarithms expanded form and in a contracted single form. So good luck, enjoy. If you have questions, let me know.